Hello everybody, how are you all doing? I myself am doing fine. We're going to continue on looking at the 2014 Fryer paper, that's the grade 9 level contest. And we're up to question number 3 in this video, so that's what we're going to be taking a look at today. So we can dive right in and take a look at question number 3. So triangle ABC begins with vertices. A is at 6, 9, B is at the origin, and C is at 10, 0, just as we've shown here. Two players play a game using triangle ABC. On each turn, a player can move vertex A 1 unit, either to the left or down, so left this way towards the y-axis or towards the x-axis. The x-coordinates and the y-coordinates of A cannot be made negative. Okay. The person who makes the area of triangle ABC equal to 25 wins the game. So it looks like we can only move A, we can't move B or C. Okay, so A can only move this way or this way, and we'll probably get into combinations as the people play the game. So A part, what is the area of triangle ABC before the first move in the game is made? So what is the area of this triangle as it is? Okay. So we have B over here. We'll say we have C over here. He's at 10, 0. B is at 0, 0. And we have A somewhere up here. He's at 6, 9. So he's 6 over and 9 high. There we go. That's A up there. So we need a base times a height. Well, here's a base and here's a height. So BC has a length of 10 minus 0. So that's going to be 10. Their y-coordinates are the same. They lie on the x-axis. They're both going to be y-coordinates of 0. So the distance is just the difference between their x-coordinates. So that's 10 minus 0. So it's just going to be 10. So what's the height? So 9 units from A to the x-axis because 9 is the y-coordinates of A. So that's how much higher he is than the x-axis, which has a constant height of y equals 0. So the area of ABC is 1/2 base times height. That's going to be 1/2. Our base is 10. Our height is 9. So that's 5 times 9. And that's equal to 45. So we have an area of 45 units to start off with. Okay. So now, if I recall correctly, B and C are written, and indeed they are. Alright, Dexter and Ella play the game. After several moves have been made, vertex A is at 2, 7. Okay, so he's gone over a fair bit and he's gone down by 2. It is now Dexter's turn to move. Explain how Ella can always win the game from this point. Okay. Well, what does a winning condition for the game look like? That might be something to explore. So before we start in on B, let's ask, what does it look like when we win? What move do we need to do to get to? What position does A need to be in order to win? Is there just one? Are there many? That's the idea. Because the best way to approach a game theory question on these types of contests, not just game theory in general, specifically these types of contests, the best thing to do is start at your winning position or positions and work backwards to develop strategies to win. That's the best way to do it on contests. Now, in real life, in real game theory, that's also a very good strategy. Another good strategy is making game trees. And there's just lots of other ways to do it. I mean, if you're serious about game theory, there are resources you can find either online or in the library. But specifically to contests, and this is just coming from experience, the best thing to do is find a winning position and work your way back from it. Okay. So a winning position is when a triangle ABC has area of 25. Now the base BC does not change. We'll say A is at XY. And you can probably see that the x-coordinate of A doesn't really matter. It's all about that y-coordinate. So 1/2 base times height. Well, the base hasn't changed. It's only the height. So the x-coordinate is irrelevant. Once we get y is equal to 5, we win. So you can't move left and win. If we move left, if L is going to win and she wins on this move and she's moved left, the y-coordinate of A now has to be 5. But since we moved left, we only changed the x-coordinate. So to start off her move, the y-coordinate had to still be 5 because it didn't change throughout her move. So we have to move down. Once we've been handed something that looks like x6, we move down and we've won. And we move 1 unit down, we're at x5, and then the height's going to be 5. So we get an area of 25. So this is the only way to win. So now we can take a look at B part in a serious manner. So we have vertex A is at 2, 7. It's Dexter's turn to move. Explain how Ella can always win. So Dexter has two possible moves. Either he moves to the left, or he moves down. If he moves down, then he's handing Ella a 2-6, and Ella can automatically win at that point. So if he doesn't, he moves left, and he gives 1-7. Now, Ella can't move down from there, because then she'd be handing him 1-6, and that wouldn't give her the win. But she can move left, giving him 0-7. So he has two possible moves, left or down. So if he moves left, he hands Ella. A is now at 1-7. Otherwise, he gives Ella A at 2-6. She brings it right down to 2-5. She easily wins at that point. Okay. So if Ella gets 1-7 for the coordinates of A, she can go left or down. Okay. So we start off. Dexter could move down, but then she's going to win. So he'll probably move left. If she gets a left, she needs to move A to the left again, giving Dexter 0-7. So with A at 0-7, Dexter can only move down. Since the x-coordinate can't be negative. Well, then Ella gets 0-6 and wins by moving A to 0-5. So in either case, she wins, either by getting it to 2-5 or 0-5. So we've explained exactly why Ella can win. Based on what Dexter does, we give her sort of a recipe for victory. So that gives us B part. C. Faisal and Jeff play the game, with Faisal always going first. So F before G, that makes sense. There is a winning strategy for one of these players. So by following the rules in a certain way, either Faisal or Jeff can win the game every time, no matter what the other player does. So we're asked three things. Which player has the winning strategy? Describe the winning strategy. And justify this winning strategy will always win. Okay. So, who would win between Faisal and Jeff? Okay. Well, it looks like, just based on our preliminary work with Dexter and Ella in the previous game, you can always move left or down until you hit that y-axis. So whoever has the winning strategy, if they're looking at something, an x comma 7, if A is at some x coordinate and 7, they'll just want to keep moving left until the other person hands them something with height 6. So the question is, who is that? Because then they'll force them over to the y-axis, and then eventually they'll have to move down from 7-0 to 6-0, and then this person will be able to win, going from 6-0 to 0-6 to 0-5. Okay. So one thing I notice is that 9 and 6 adds up to 15, and if we move left or down, we change that sum to 14. Then moving left or down changes that to 13, and then moving left or down changes that to 12. So if Faisal goes first, he starts with an odd number being the sum of the coordinates, and he ends with an even number being the sum of the coordinates. And then Jeff starts with an even number being the sum of the x and y coordinates of A, and he leaves it. He hands Faisal off with an odd sum for the coordinates again. Now, this will probably work its way down, just as with Dexter and Ella, to A having to basically be forced to be at 0-5. 0-5. And that's a sum of odd coordinates. So, Jeff, who ends his turn with a sum being odd, sum of the x and y coordinates of A being odd, Jeff should be the winner. Okay, but we need to explain that. We need to strategize that. We need to write things out. So I'm going to write down my observation that so after Faisal's turn, the parity, which is the oddness or evenness, so the same is true for Jeff. So what we've done is we've taken an arbitrary set of coordinates for A, x, and y, and we've shown that after their turn, no matter if they go left or down, the parity, so if a plus x was even, -1 it'll be odd. If it was odd, then -1 it'll be even. So the parity, the oddness or evenness of the sum of a's coordinates has changed. And this analysis was not unique to Feisel, so the same holds true for Jeff. Okay, so we know that Feisel takes an odd sum of a's coordinates, and when he's finished his turn, a will have an even sum of the x and y coordinates. And Jeff is the opposite. He'll take in an even sum. He'll start his turn with a being at something like 6, 8 or 2, 4, something like that, an even sum. And he'll end his turn with an odd sum, something like 1, 6, something like that. Okay. So, I'm pretty sure it's Jeff who wins. And so what can he do? Anytime Feisel gives an even coordinate for y, Jeff needs to also go down a step. So if Feisel goes from 6, 9 to 6, 8, then Jeff needs to go from 6, 8 to 6, 7. Alright, so if he does that, then that means he's the one who will first make y have a value of 5. The y coordinate have a value of 5. Okay, so that's the idea for his strategy. Now we'll need to sort of prove that it works. Okay. So how would he go about accomplishing this? So if Feisel moves left at the start, then that gives us 5, 9 for Jeff. And Jeff wants to keep that y coordinate odd, so he would go 4, 9. Okay. So I think we can add to this. So we're just going to have him copy whatever move Faisal made. So it's going to either go left twice or go down twice, and that way the y coordinate will not change. So either it's going to move left twice or move down twice. So how does this ensure that it always wins? So since we can't keep going left all the time, eventually we'll have to start going down. And that means the game will always end. So if we can just show, since the game ends, if we can show Faisal isn't ever the winner with this strategy, if Jeff plays like this, then Jeff must be the winner. So we're going to use a little proof by contradiction. We're going to assume Faisal won. We're going to show that this is utter nonsense, and that must mean that we have a contradiction, and then it follows that Faisal is never the winner, and so Jeff must have won. So he must have started at x6 and then moved down to x5. The problem is, if he starts his turn at x6, so just last turn, must have ended with a at x6. But this is the opposite of what our strategy is. And we know that we can always keep y odd at the end of Jeff's turn. So our work we did over here, if we mirror Faisal's move, we get a change of the x-coordinate by 2 or the change of the y-coordinate by 2. Okay. So after playing around with it for a little bit, we figured out that Jeff, he'll probably win. And the way he does that is he ensures that at the end of his turn, the y-coordinate of A is always odd. Okay? Not only that, I mean, that's his goal, but we show why this is always possible. So if we start at xy, if Faisal, whatever Faisal does, we're just going to mimic it. And that will either not change y at all at the end of Jeff's turn. So if it starts odd at the start of Faisal's turn, it'll end odd at the end of Jeff's turn. Or it goes down by 2. And an odd subtract off of 2 is still odd. So at the end of Jeff's turn, we can always make sure it's odd because the game starts off at Faisal's first turn with A at 6-9. 9 is odd. So Jeff can always make sure that the y-coordinate is odd at the end of his turn. If Faisal were to win, as we remarked a little while ago, you'd have to be at something like x is 6 and move down. You can't move left and be the winner. Okay? So for Faisal to start his turn at x6 and then win, that would mean that Jeff ended his turn with x6, but Jeff's strategy is to always make the y-coordinate odd by the end of his turn, and we know he can accomplish this. So we have a bit of a contradiction. Following the strategy, this won't happen, which means that Faisal will never win with the strategy, and that means that Jeff always wins. Okay? So it might seem a little tricky. Play around with it yourself. I mean, grab a friend and play the game yourself and follow this strategy. You'll be able to convince yourself it wins for Jeff all the time, and you might be able to come up with a clearer explanation than I. But I definitely think that that's the best strategy for Jeff, and Jeff is the one who wins. So let's check. We know who's got the winning strategy. It's Jeff. We know his winning strategy. He makes sure that y is always odd at the end of his turn, and he accomplishes this. So we actually know the strategy accomplishes this by making sure he mimics whatever Faisal moved. If Faisal moved left, Jeff moves left. If Faisal moves A down, then Jeff moves A down. And not only that, using a sort of proof by contradiction, we show that this will always result in a win for Jeff. And that concludes that question. It's a nice little game theory question. And we've got one more to go. We have question number 4, but we'll leave that for another video. So I'll see you guys then.